So I'm Bálint Tahi from PPM Robotics CS from Norway. Actually, I'm from Hungary, not Norway, but I'm working there. We are an integrator high-tech company in Norway, developing cutting-edge industrial technologies. Really nice buzzwords. It's the presentation is full with these pretty nice buzzwords. Collaborating with Nachi, OTC, Hyundai, and many other Korean and Japanese companies. Basically, we have partners all over the world. Even in Hungary, we are working with Lazram, who is a laser company, and we are using ROS in many of our projects. And we are part of the ROS-Industrial community, full members. As I can remember, 4 or 5 years ago, I cannot tell you the exact date, but I don't think it matters. And we are also hanging around in ROS Asia, ROS-I Asia, because of basically the Korean and Japanese partners. We also participated on the conference in Singapore and in the USA as well, but we don't have partners in USA, but it's really nice to be there on the ROS conferences. We are ROS-In champions, which means we have 2 ROS-In projects currently. ROS-In is a Horizon 2020 supported ROS-I quality assured project basically. So we are developing new components for ROS, which are quality assured, because we can feel that's the biggest issue with ROS, that the components are not really quality assured and unit tested and documented. So in this project, we are trying to achieve the level we want. We would like to see in every other components in ROS. And if you are not familiar with ROS-Industrial, it's a project to bring ROS softwares to industrial level and to manufacturing. So I think we have a quite good collaboration with ROS-I. That's why I'm here basically, because they invited us. About PPM Robotics CS, we are located in Trondheim, almost middle of Norway and next to hell. We are always trying to tell we are close to the hell. Yeah, basically that's the name of the airport. And there's supposed to be this northern light, which I never saw in the 8 years I'm working in Norway. But it should be there. I'm not sure why I haven't seen it. Yeah, of course. We have partners in Narvik as well, but I don't. That is too cold for me. My Hungarian body won't survive there for long. What we are doing, we have industrial projects like automation systems, feasibility studies, and we have some customized devices as well. We have some products, mostly software products, not in the list, but first software was Sport S3 for ABB robots. Then my boss had the idea that we should make something for Nachi as well, so we made FlexGUI, which is an extension for Nachi robots and also for OTC robots because they are using the same controller. And we are selling industrial robots in Norway, mostly Nachis, but we have some OTCs as well, and now we are trying to collaborate with FNP as well from Sweden, not Sweden, but Switzerland. And we also have a lot of research and development projects and trainings and consultancy with our partners. And most of our research and development projects are supported by the Norwegian government or the EU. I hope I will find my next slide because it's a bit yeah, it's the default settings on the printer. I'm not sure why I can see only 2 images here, because I'm pretty sure I'm included much more. Why are they missing? They just disappeared. First, when we checked it, it was okay. Anyways, so here you should be able to see much more projects. We made. Yeah, it's Black Friday. Yeah, basically most of our work is missing. We have many grinding projects and welding projects, robotized welding and grinding projects, some machine vision projects, and UIs we made for our customers, which you won't see in this presentation. But maybe we will send you the right one after this meeting. So here you can see some of our projects based on ROS or using ROS. FlexGUI 2.4 is not the best example, to be honest, because that's the UI extension for Nachi robots. But we made it ROS compatible, because after 5 years or something like that, when we first met with ROS. So basically, Nachi or OTC robot can be used ROS and not joint levels. So we will arrive at the point when I will say we are not trusting ROS as a robot controller. It's not as reliable as the robot controller what the vendors are making, but you can access all of the variables from the robot, and I think, and we think, this is the most important thing for a robot controller, that you know all of the integers and strings from the robot. This is what we cannot use, for example, with the ABB driver or KUKA driver. I don't think it's available, only the joint level driver, so I can control the robot from move it, which is not acceptable right now in the industry, I think. We have FlexGUI 4, which should be the basic UI, easy to use UI for ROS. It's fully ROS compatible. You can assemble UIs quite easily, and you can program it. I will talk all of these projects a bit more. It's just an overview. We have the machine vision project. It's with a Korean partner, and we are using many parts from ROS, OpenCV as well, to recognize. Yeah, there is that small image is from our machine vision project. So there is a box with small work pieces, and the robot needs to pick up one at a time and put it into a washing machine. So it's controlled by ROS. We have this ROS-Weld and black box. These projects are the ROS-in FTPs we have right now. ROS-Weld is a robotized welding application based on ROS. It's fully open source and free. There will be some parts like the AI-based filling of the groove, which is our part, and that's not free, but the framework itself and how it's working, it's documented, quality assured, and working right now. It's in our GitHub page. Basically can be downloaded, and it's working. There is the black box, which is and which should be an extension of ROSBag. I will talk about more. And we have a Contiga grinding cell, which is not working, not controlled with ROS, but the UI is based on FlexGUI 4, and we are communicating with ROS and transferring the variables through ROS in this project. Oh my God, I just looked at the text and I cannot read it. So why are we using ROS? Many of our projects starting, okay, what kind of devices should we use? And we pick 10, and from 4 different vendors. Okay, how should they communicate? And then, of course, many project managers says, it's easy, you just connect them to each other and it will work. No, there is not a magic box in the market which supports this. I mean, for free, of course. And many times we need drivers for devices, we need applications. We don't want to reinvent the wheel, and that's the most important. We don't want to start a project from zero and write the code which someone else already made. Why would we? I mean, we need the testing and everything from scratch, and that's just stupid. And ROS provides a lot of drivers, application, frameworks, examples, documentation, wiki, and there is a big community behind. I mean, if you go to the ask.ros.org or something like that is the name, you ask a question, and I'm sure that in 2-3 hours you will get some answers, and that's incredibly fast and really helpful in some cases. But there is always a but. Where is that? Oh my God. It's totally mixed. I think that's the dark side of ROS or something like that. Yeah, so...
Weaknesses.
Weaknesses. Okay. I wrote dark side. It's not 100% translated. Anyways, there is something like the quality of the codes are not the best, I would say. Why? Because a lot of really enthusiastic people, just amateur, I would not amateurs of course, but who wants to learn ROS, sending some components, and we would assume it's ready to use, but it's not. It's absolutely not. And a lot of university students are working with ROS, and maybe their vision of reliability of a code is not the same as the industry has right now. Therefore, you will need a lot of development, still a lot of development to make an industrial-ready ROS application from these components. Of course, there are some, and of course, the base of ROS, so the ROS core, ROS master, and the communication layer is extremely reliable, and we never had problem with that. But the nodes and the components we can find on the internet are not at that level. And the other program, if you have to change someone else's code, it's really hard. I mean, someone else, you don't have that brain, you don't have that thinking, you have to go through the code, but it's much better than starting from zero. In some cases, of course. And the other problem is the lack of documentation of some components. So that's why I'm saying it's really good to start a project with ROS, but you have to consider that and you have to make it in count that there will be problems. There are always has problems. Summary. Yes, I think I'm already told it that ROS is a really good basis of a project, but we still need some development, which is not a problem if we don't need to reinvent the wheel. But it won't be an easy job. And you need a lot of experience in ROS and in software engineering to understand everything, and from robotics as well, of course, because these components mostly made for robotics. FlexGUI 4. So, as I already mentioned, this is our vision of an easy-to-use UI. It's something like a mobile UI, but it's not a mobile UI actually, because you can use it on a PC as well. This should be our UI for ROS. We are using this UI in every of our ROS projects or ROS-based projects, and actually we are using this UI in projects where we are not using ROS as well, because it's quite well-defined, the interface, the WebSocket protocol, but the ROS bridge offers, so we can implement the drivers for FlexGUI 4 in everything basically. We are trying to provide a nice looking and easy to use UI. It's like you have elements, UI elements, buttons, and this kind of things, so you can drop down them to the UI and program them in JavaScript. Why I am showing this? Because FlexGUI 4 is open source and free, and you can find it on GitHub. So if you need a UI and you don't want to reinvent the wheel, go to our GitHub page, download FlexGUI, and it will work out of the box with ROS. So you can have all of the topics, and you can call the services with a button press. It's quite easy. The documentation and everything is included. FlexGUI 4, in FlexGUI 4 we also has a separated interface to Nachi robots. So it's a bit easier to use the FlexGUI 4 with Nachi, but it's not impossible to use it, for example, with a KUKA robot or ABB robot. You just need to implement some small interfaces, but it's JavaScript. It's not a really hard language to learn. FlexGUI 4 is a AngularJS application. This is a 5 or 6 years old project. That's why it's an old framework. But we are working on the new version, which implements the Angular 8, the latest Angular version, and we are supporting Android, Windows, and iOS as well. So you can use FlexGUI 4 as an HMI. From remotely, you can control your cell. You don't need to buy an industrial PC or industrial tablet. It's working with any modern web browsers. So I think this is a really good feature, and with the help of ROS, you can control your cells quite easily, and it's free. It's on the website. So I think this should help you in making prototypes, or even to go to the customer and assemble a new UI, and hey, look, it's working out of the box. Usually they are happy about this. And here is our, not the latest, because the latest ROS-in project is the black box, but we made this ROS-Weld project in 2018. This is a robotized welding application with some kind of machine vision. It's not machine vision because we are reading the laser sensors and trying to position the robot based on the readings. This should be an innovative ROS-based framework. It's your decision to decide it's innovative or not. We think it is. And it uses the same UI, so it's FlexGUI 4 based UI. If you don't like the UI, you can just edit it. It's completely open source and documented as well. And the framework is built upon ROS components already on the market and on our previous research. So this image is taken in Rainpower AS. They are a big water turbine manufacturing company. I mean, one water turbine is like at least this big from the ground, and they are welding it with robots. There are a lot of research behind, and he's Csongor, my colleague. You already met with him. His PhD is based on robotized welding.
Is it a proof of concept, or is it an actual?
This is an actual project.
Is used in production.
Yes. Yeah. All of our projects are used in production. And that's why we made this ROS-in project, ROS-Weld, to share all knowledge in robotized welding and in ROS. So, oh my God, it's here. Okay. So in the project, there are 3 Norwegian companies: PPM Robotics AS. We are coordinating and developing the software. Mechatronics Innovation Lab AS, who is a catapult center for industrial projects and technologies around Norway, and also want to share the knowledge of ROS as well. So we have many small ROS projects there. We have 5 small installations, both ROS based, and Rainpower AS, who is the basically the manufacturer of these really big water turbines. And now they are trying to add, I think one blade on a water turbine needs 200 welds, because the current ones are much bigger than this. And it's really hard. So it's with human welders, it takes an insane amount of time, because from 8 hours they can work only 2 because of the working conditions. But the robot can weld 24 hours per day, and this project helps them to plan the welding itself. So how they fill up the groove, how they connect the blades to the ring. The budget is 300k euros, and we got 100k euro support from ROS-In, which was a really big help. The goal, mostly I already told you the goal. So the goal is to robotize the welding because of the hard environment, and the pilot case will be so this will be installed as a pilot project at Rainpower, but the previous welding project, CoroWeld, which was not based in ROS but had the same principles as this project, are working in Rainpower. These are the functions we are offering with ROS-Weld. So you can plan, simulate, control, observe, store your data with ROS-Weld, and it's totally modular. So if you don't want to use a Nachi robot, no problem, just implement the same interface to ROS and it will work. So it's totally transparent, and you don't need to use, for example, the laser measurements. You can work without that, with manual teaching. It's not a problem. I don't think that this slide should be here, but anyways, our problem was in this project, and why we choose ROS, that we are using many components. As you can see, we are using in MIL, the Mechatronics Innovation Lab, we are using this type of welding equipment. I'm not sure about the name. But in Rainpower we are using an OTC welding equipment, so it's different types. How should we connect both to our system? We didn't know. And they had different laser scanners, but they want the same result. They have different cameras. They have different welding cameras. How should we connect everything in a flexible way? So therefore we went to ROS, because it defines a really good interface, well-defined interface, a flexible one, and it's really easy to write drivers for ROS. I mean, everyone can do it. Of course not, but it would be really nice. Sure. And these are the components we are offering in this project. So because of this project, we uploaded a free and open source OTC driver. It's only a base of a driver, of course, because you will need to customize it if you want. But you have everything to understand how it's working, and it offers the movements and every interface to be able to move a robot. It's Fronius. It's a Fronius VPS, so we are offering an OTC and a Fronius VPS driver. So if you want to use them in your projects, you can download them from our website and from GitHub. We are using MEL Elan lasers and micro epsilon lasers. The drivers are uploaded. We are using IP camera. This is a good example of how we changed some of the already existing drivers to a bit more usable and quality assured drivers, because this was an open source driver on ROS. We downloaded it, customized it, tested it, and uploaded it into this project. And we have a camera, welding camera, which is basically a HDMI welding camera, so it doesn't really need a really special driver. This is how we are using ROS basically. So with FlexGui4, with the UI, we are communicating through ROS bridge, and everything is connected to ROS, basically to ROS core. And but when we are talking about ROS, we are referring to the communication layer. That's the thing we are using most often, not its parts like MoveIt and RVs, because the customer doesn't care about RVs. Why would they? I mean, they don't want to use Linux at all. They are not highly educated person who can use Linux and RVs, because they still need programming, or at least programming knowledge. So we are connecting all of the devices with our drivers to ROS, and we are communicating with the core through ROS. Therefore, we doesn't need to write the communication layer. And in this project, we are also using MoveIt and RVs, but not as the main UI or not as main components, but for the simulation. So in this case, you can change between the real robot and simulation. So you can assemble your path and weldings in a simulation environment, which is offered by RVs. You can plan the robot movement with MoveIt, but the system uses MoveIt automatically, so you don't need to know how it's built up and this kind of things. We are using ROS3D, which is an open source library as well for displaying the simulation in a web browser. And PCL, so the point cloud library, is for the laser scanner. Pyros is for the core, so the ROS-Weld core is in Python, and ROS bridge for some connections. Actually, we are using it not just for FlexGui4, but for some other drivers as well. In our laboratory, and this is a picture from our laboratory. The Rainpower's installation, of course, a bit different and much more complicated than just two metal pieces, and they are not welding them together. But we used for this project an HMR20 robot, an OTC welding equipment, the MEL M2 Elan laser scanner, Cisco IP cameras, and the Samsung Galaxy tablet for controlling the cell. So that's what makes it really flexible, FlexGui4, that you can run it on your tablet, go near to the welding machine and adjust the position really precisely next to the robot. Of course, sometimes it's not safe, but who cares about safeness? I mean, even Rainpower goes next to the welding equipment because they need to. This is our other project, Blackbox, which is another ROSIN project. It's for monitoring, and basically we are storing the data in ROS bridge, and then you can define expressions. If something happens, you can have a notification that something happened in your cell, in your production, which is not in your office. And imagine you are sitting in your office working on something else, and you got a call from your biggest customer that, hello, my robot cell just stopped. Why? I don't know. Then you have to go there. The production stops for 2-3 hours. That's a really big problem. Therefore, we are developing this software to get instant notification from the robot cell and all of the variables and all of the things flowing in the robot cell. So everything you push to ROS or publish to ROS will be in a bag file which we upload to the cloud. You can download it and investigate what was the problem. And this is a really important thing in the industry. It was missing. So according to our research, it was missing from ROS, and of course you can buy it from Siemens for really expensive. I mean, it doesn't really worth it, I think. But this is an open source solution for this problem. So we are using the same things, FlexV4 as the UI, so you can control a black box from this UI. We are using ROSBag, which is really reliable. I suggest to use it because you can play back your data, you can stop it, you can check everything, what happened after and before. It's developed in C++ and Python, and we are providing drivers for cameras, and also the part of the Nachi driver are uploaded there. Will be uploaded because it's not the milestone one is not accepted yet, so it's not published. You are working on it, I know. And this is how it's built up. So there is the local system, which is an installation, maybe a pick and place installation or something else. It doesn't really matter as long as you are providing your variables to the system. We record these variables and compare them with the expressions you are defining, and if something is wrong, then we are sending an email and uploading the package what you can download and investigate on your remote machine. So you don't need to go there and spend many hours to figure out what was the problem, because of course when you are there the problems are not happening. It's like when you have problems with your car and you go to a car mechanic. What's the problem? This is the problem. I cannot see it. So this can help in these cases. Yeah, we have a machine vision project as well. This is installed in Korea, Eugene Mechatronics. This is what I mentioned, that we are taking pictures with a PhotoNeo 3D camera, which is ROS compatible, and maybe this is the most interesting part. So the PhotoNeo camera is sending point clouds to ROS, and with the help of OpenCV, that's the Vision OpenCV package in ROS, and the PCR ROS and the transformation packages, everything is in ROS. We are calculating the, ROS, basically ROS calculating the orientation and position of the workpieces, so we can pick them up with a robot. This is a good example for the customization of the ROS packages, because yes, they are there, but I haven't heard about the parameters in my life, connected to the vision system, and we had to customize them to have a really precise image of each workpieces, to be able to determine that there is a workpiece and there is a workpiece, and what is their orientation. So the challenge in this project was to find the right parameters and the understand of these parameters. This is a lie, because we are not using a Nachi robot in this project. That was the plan, to use a Nachi robot, and we went there, and in the final minutes they said, we don't have a Nachi robot. You have to use a Hywind robot or a Hyundai robot. So in 4 hours we wrote the driver for a Hyundai robot, and it's working with the system. We tested it with Nachi, and we changed it to Hyundai in 4 hours. It was not a problem because the interfaces are well defined in ROS. And I think that's me. So, so this was some of our industrial experiments. I don't have a business card. I left it in Norway and I came from Hungary. So you should take a picture of this or it will be in the presentation. Thank you very much. And if you have questions, please ask in some language.